Welcome to all. We are in the next new topic, that is moment of inertia of a rigid diatomic molecule. So before this topic, we known about what is the moment of inertia and what is the equation for this moment of inertia for a single one. And now we have expand this moment of inertia for a diatomic molecule. So what do you mean by diatomic molecule? There is the two atoms with different masses which are in the bonding. It may be a covalent bond or anything. More number of examples are there for diatomic molecule. So let us consider the rigid diatomic molecule containing two atoms of masses m1 and m2 which was separated by a distance x. Let this diatomic molecule be considered as a system connected by a weightless rigid rod. So now this is not a bonding, this is a rigid rod because we are in the mechanics. So there is any two particles which was connected by the rod. We have to calculate the moment of inertia. So the center of mass of the system, that is for this diatomic molecule, the center of mass lies between two atoms and is denoted by the point O. Here the mass m1 is very lower mass. According to the figure, m1 is lower mass. According to the figure, m2 is higher mass. So the center of mass is not exactly at the center of the rigid rod. It is moving towards the m2. Why? Because the m2 is higher mass, so the center of mass is locating near the edges of the m2 mass. So let x1 and x2 be the distance of two atoms from the center of mass. So the complete distance is x according to the center of mass. For the mass m1 the distance is x1, for the mass m2 the distance is x2. So from the figure we can write x is equal to x1 plus x2. So we have to calculate, we are in the position to calculate the moment of inertia. So before that we need to know about the m into x. So according to the figure we can write m1 x1 is equal to m2 x2. Let this equation number 2. From equation 1 we can write x1 value and we can write x2 value. So x1 x2 can be written as x minus x1. This is the equation number 3. If we need to write x1, we can get x1 is equal to x minus x2 in the next slides we will get. So now we can concentrate x2. Substitute this equation 3 in equation 2. So what is the equation 2? m1 x1 is equal to m2 x2. So substitute the value of x2, that is m1 x1 is equal to m2 into x minus x1. m1 x1 is equal to m2 into x minus m2 x1. So bring all the x1 on one side and x on the another side. So m1 x1 plus m2 x1 is equal to m2 into x. Here x1 is common for both m1 and m2, so take it outside. So m1 plus m2 of x1 is equal to m2x. So we got x1 is equal to, bring all the things here this side. So x1 is equal to m2x by m1 plus x2 m1 plus m2. This is the equation number 4. The same work we have to do for finding x1. Finding x2. So for finding x2 we can get the equation x1. We will write the equation x2 means we will get x1. We will write the equation from equation 1 that is x1. From equation 1 we can get a final equation x2. So from equation 1 we can also write x1 is equal to x minus x2. Find the same work we have to do. So substitute this equation number 5 in equation 2. We will get m1 into x minus x2 is equal to m2 into x2. So after some rearrangement and multiplication we will get m1x is equal to m1 plus m2 into x2. So finally we will get x2 is equal to m1x by m1 plus m2. So we got x1 and we got x2 in terms of m1 and m2. So bring this two equation in the combination of moment of inertia. We know the moment of inertia formula, that is I is equal to mx square. Here two m's are there and here two x's are there, that is moment of inertia of a diatomic molecule with respect to any axis passing through center of mass of the system can be written as I is equal to m1 x1 square plus m2 x2 square. So substitute this equation 4 and and 6 the equation in 7, that is the equation 4 and 6 is x1 and x2. So substitute here I is equal to m1 into m2x by m1 plus m2 the whole square plus m2 into m1x by m1 plus m2 the whole square. So multiplication and rearranging takes place here, and finally we will get I is equal to m1 m2 by m1 plus m2 into x square. Here the masses can be considered as a symbol mu. This mu is called as a reduced mass of the system. So in terms of mu, I can be written as I is equal to mu x square. This is the equation 9 represents the moment of inertia of the diatomic molecule. Thank you.